This is Series Circuit Skill 1, and we're going to go through and do the calculations around our circuit. We've got our source, switch, one load, a resistor, and a fuse for our circuit. Now we can start filling in some of the information that we know already. We know that the resistance of our resistor here is going to be 10 ohms. And since it's the only load in the circuit, I'm going to take that same resistance and just put that over here as our total resistance. We do have the fuse and the switch, but they don't have any real resistance to add to the current flowing around our circuit. So that gives me one of my first totals over here. I also know that I only have one source for the circuit, so I'll take that 12 volts that is our applied source and fill that in. Now here I've got 2 out of the 3 components that I need to use Ohm's law. Remember Ohm's law, E equals I times R. Or we can do variations of that. Since in this case we're missing I, we can go with I equals E divided by R. So if I take my 12 volts and my 10 ohms, I'm going to take 12 divided by 10, and I see that I have 1.2 amps of current flow. Since this is a series circuit, I know that I can take that same current and apply it to every component because there is only one path for current. Current is constant as it flows around the circuit. So I can apply that same current value to my resistor. So I know that the current going through the resistor is 1.2 amps, and with 10 ohms of resistance, I can use Ohm's law again and see that E equals I times R. So multiply those two together and we get our 12 volts. So for the circuit with only one load, all the applied voltage will be seen at that load. We could do some quick calculations for the switch and the fuse as well. If I wanted to go the voltage of switch 1 and the current through switch 1 and the resistance of switch 1, I could do them as our circuit is operating. So when the switch is closed, the voltage that I should see there and the current going through there and the resistance. I know that the current going through the switch is going to be the same as everywhere else. I found the total and I know that same current is going through the resistor, so I can apply that same current. I know there's 1.2 amps of current going through the switch when the circuit is operating. That also means that the switch must be closed for it to operate, so that the resistance should be 0 ohms. And if I multiply that resistance of 0 ohms times the 1.2 amps, I see that I really have 0 volts there. I can do the same thing for the fuse. I can look for my voltage of fuse 1, and current through fuse 1, and resistance of fuse 1, and find out what each one of those equals. I know I've got that same amount of current, 1.2 amps, flowing through the fuse. The resistance of a fuse, again, is 0 ohms. Should be any opposition to current flow there until the fuse would open. So if I go 0 ohms times 1.2 amps, I would see that there are 0 volts there. And that works with Kirchhoff's laws as well, saying that I have to add up the sum of the voltage drops as I go around my series circuit. So if I add my 0 volts here, and my 12 volts there, and my 0 volts down here, all of those must equal my applied voltage.